Due to an oversight on my part, we need to take a quick look at what the graphs of power functions with negative exponents look like. You should take some brief notes in your binder on these. So to get started, if we were looking at the power function x to the negative 1, of course that negative 1 exponent means we basically have a fraction, right? 1 over whatever that is to the first power. So this is really just taking the reciprocal of x to get our y values. If we make a little table, we could start plugging in, like I'll start at 1 and then go to 2 and 3, and we can see that, our y values are going down gradually as our x values increase, right? And they appear to be kind of heading down towards the x-axis. And we can kind of know they're never going to get below the x-axis, right? Because you're never going to end up with a negative value by plugging in positive numbers here. As we look at values between 0 and 1, of course, taking their reciprocals gives us larger and larger y values. So we're going to have the point, 1/2 and 2, and then 1/3 and 3. And those values keep getting closer and closer to the y-axis as our x values get closer and closer to 0, but they just keep going up. So it looks pretty clear that we have a curve that does this. Pardon the waviness of the line, but you can see the basic shape here. Right now, of course, when we plug 0 in, we have 1 over 0, and that is undefined. So we're not even going to plot a point there. And then when we plug in negative values here, right, we're going to basically have the same thing happening just for negative. So negative fractions like 1/2 are going to be -2. And as we go out to like -2 and -3, we're going to be plotting points that are close to the x-axis again with their reciprocals. So it should look something like this. Okay, you get the basic idea except for the waviness of the line. And the graph that we have here is what we would call the basic hyperbola. That's essentially what we have here, where we do have a vertical asymptote at 0, y at x equal to 0, and we also have this horizontal asymptote of y equal to 0. All right, so what is it going to look like if we have x to the -2, where when we plug in our numbers, we're squaring them first before we take the reciprocal? If you think about it, it's not going to change things too much. I mean, when you plug in 1, you're going to get back 1 still. If you plug in 2, you'll just have 1 over 2 squared, so 1/4, and 3, 1 over 3 squared, which would be 1/9. So you're still going to have these small y values when you're plugging in whole numbers. And when you do the fractions, you're basically going to have the same thing happening where you're getting bigger whole numbers, right? So if I plug in 1/2, I'm going to square that, I get 1 over 1/4, which will flip it and become 4. So we're essentially going to have the same thing happening for positive values. Now when we go to the negative side of this, we're basically going to have the same kind of thing happening, except now all these values that were negative before are going to get squared and become positive, right? So the curve will look like this. And it will actually be symmetric, right? Because if I plug in +2, I'm going to get 1/4. If I plug in -2, I should get back 1/4. So we're going to get back the same y value whether we plug in a positive or a negative. All right, so this is the basic pattern of these graphs where the exponent is negative on a power function. So let's quickly take a look at other ones. Just to verify what we did, we can see here's the basic hyperbola that we were getting when p was -1. And here all our values are being squared. We got p to be -2, and there's the graph we were sketching. So what do you think is going to happen when we go back to an odd exponent, something like x to the -3? Well, I'll give you a choice. It's going to be like one of the two graphs we saw before. So which one do you think it'll be like, the x to the -1 or x to the -2? Well, hopefully you didn't have to think too long on that. Yes, it's going to be like x to the -1, the other odd one. So our graph here is just going to, that was not a very good graph there, but it's just basically going to mimic what we did for x to the -1. It actually is a little steeper, like it's gonna go up a little faster and come down a little faster, but we're not really worried about that. It's mostly the general shape is what we're looking at. And then, of course, x to the negative 4 is going to make sure that all the output values are positive. So it's got a curve that looks like this. Here's our check on what we just sketched with our exponent being negative 3. Looks a lot like when it's negative 1. And here it is when it's an even negative, like negative 4. It looks a lot like negative 2. So now that we've established the pattern with the even and odd negative exponents, what those graphs look like, now we're going to throw into it, what if we have some coefficient in front that's either negative or positive? What's that going to do to the graph? So I've rewritten it so you can still see it is a power function, right, on both of these. So why don't you pause the video and sketch what you think this graph will look like. Don't worry about hitting specific points, but just the general shape. All right, see if this is what you got for letter E. Hopefully you didn't sketch this red graph. This is what it would have been had it, of course, been a positive x to the 5th. So if it's negative, it's going to look like this. Yes, the negative just reflects the graph, right? What was up here now gets reflected over the horizontal axis, becomes negative, and what was negative before becomes positive, and it's up there. All right, perhaps you went ahead and also did the next one with x to the 6th. Let's think about it. It's got an even exponent, so an even negative exponent. So normally we would expect it to, be doing this thing, right? Where we're up here, but because, let's see, and with a positive coefficient in front of it that's not negative, it's going to stay that way, right? So we'll just go with this curve. I'm trying to keep it looking right. That's not quite right there. It's supposed to be getting closer to the y-axis. All right. Here's a look on the calculator when the exponent's an odd negative, but we also have a negative coefficient. I believe that's what we were graphing. And here's a look at an even negative coefficient, and still with having a positive, an even exponent, negative exponent, and a positive coefficient. So give these last two a try by pausing the video, and then we'll see if you got what I'm going to get. Thanks for doing that. See if this is what you have. So here we have an odd negative, looks a lot like negative 1, and with a positive coefficient, we're really not going to change anything, not going to flip it. And over here we have the even negative exponent, so it's normally would look like the negative 2 one, but since we have that negative on the coefficient, it gets flipped, and it's looking like that. All right, so I think you've seen all the variations of what a power function can look like when it has a negative integer exponent. Just to corroborate our results, here's what the calculator got for that 8x to the negative 7. And here's what we have when we have the negative 8, so a negative even exponent. I didn't go with negative 15 just because my slider wouldn't go that low, but negative 10 is about the same kind of thing. So as long as it's negative, it's going to flip it over and head down. So now when you run into these when working with rational functions, remember what these graphs look like, because they will help you understand the long-run behavior of those rational functions.